We are still in Module 1 and we are doing Section C today. And we've been working on linear equations. And if you remember, a linear equation has the variable x to the first power, which means we're only going to have one solution. What we're going to deal with today is those linear equations that have the dreaded fractions and decimals in them. So let's go to our class notes. And if you look, the first thing I put in the notes is procedure. We talked about this procedure in Module 1A and 1B, but we're going to talk about it today. And I want to make close point to look at step 2. When you're solving a linear equation like we saw the last time, you're always going to distribute and get rid of parentheses first. You always have to free up the terms. But after you do that and all the terms are free, before you start putting terms together, if there are fractions or decimals in your linear equations, it would be easier to get rid of those kinds of numbers and get in whole numbers, integer values. And that's what I'm going to show you today. Tricks on how to change all your linear equations to have only integer values, which are the whole numbers that are positive or negative. And then after you get rid of that, you follow through the same procedure we did in the previous modules. So the purpose of removing the fraction and decimals is very simple. It's to make the equation easier for you to work with. It is easier to work with integers, whole numbers, versus decimals or fractions. So if you look up here in our notes, we have two equations right now that are linear. They have x's to the first power. But if you look, you could see that the coefficients, the numbers in front, are decimals. So I'm going to teach you today a little trick to get rid of those. So let's go up to the whiteboard. Okay, if you look at our first equation, 2500ths x plus 1/10 x minus 3/10 equals 1 and 1/10. I want to solve this equation for x. I have no parentheses, great, but I don't want to have to deal with decimals. I don't have a calculator handy, so it would be much easier if I could make these decimal numbers into integers, whole numbers. So the way we do that is we think common sense. Each one of these decimals can become a whole number if we move the decimal point to the very end, the right. So that's what we're going to do. Now, if you recall from arithmetic, elementary math, when you move the decimal point to the right, you're really making the number bigger, so you're doing multiplication. The key here is you have to move the decimal point the same amount of positions because you have to keep balance in your equation. Remember, an equation is just like doing a recipe. If I'm baking chocolate chip cookies and I decide that I have to double the recipe for more people, do you just double the eggs or double the sugar? No, you have to double all the ingredients to keep the recipe balanced. So the same thing here. If I want to move the decimal point to the end, we're going to have to move the same number of positions. So if you look, I'd have to move this decimal point 2 positions to the end to make that the number 25. Well, that means every other decimal has to move, every decimal point has to move 2 positions to the right. And that's what we're going to do. When you move the decimal point 2 positions to the right, you're really multiplying by 100. Because in our number system, moving 2 places to the right is the hundredths place value. So we're not going to actually show we're multiplying by 100. We're just going to do this little trick of moving the decimal point. So we move it 2 to the right, and that would be 25x. If we move this decimal point 2 places to the right, it doesn't become the number 1. If I come over here and write that decimal number, 1/10, and I move the decimal 2 positions to the right, we're going to have to add a 0. So that becomes the number 10. So don't worry about the variable. And now you leave the x. So the same thing here. If we move this decimal 2 positions to the right, that decimal point, now we have 030, which is 30. And if we move this decimal point 2 positions to the right, it becomes 110. Now you have a linear equation that you guys can work that has integers, whole numbers. So now we're going to follow our steps. Step 3 says to CLT, collect like terms. So we get 35x minus 30 equals 110. We're going to add 30, we're going to get 35x equals 140. The opposite of multiplying is doing division. And we're going to get x equals 4. Isn't that nice? Let's try another example. So if you look in your notes, as I get the eraser here, our next equation with decimals is a little bit bigger. It is 12 hundredths x minus 6 plus 6 hundredths x equals 8 hundredths x minus 7 tenths. So again, if you follow the procedure I taught you in the previous modules, the first step in solving any linear equation is to do what? That's right, it's to get rid of parentheses. So guys and gals, you can't deal with the decimal points yet. The decimal numbers have to stay until you get rid of the parentheses. So we're going to have to use what property? That's right, we're going to use our distributive property. And we're going to distribute to get rid of our parentheses. Now, no sweat here, you don't need a calculator. To multiply a decimal, it's just like multiplying whole numbers. If that was 12 times x, you would write 12x. So 12 hundredths times x is 12 hundredths x. To multiply this decimal to this whole number, come up the decimal point. If it was 12 times negative 6, it would be negative 72. Now you got to put the decimal point in. There's 2 positions behind this decimal point. So in our answer here, there's got to be 2 positions behind the decimal point. So 12 hundredths times negative 6 is negative 72 hundredths. Now we'll bring all the other terms down. Remember we talked about we're going to do a lot of writing and copying in college math. Okay, great. Now that you got rid of the parentheses, now here's your opportunity, step 2. I don't like decimals as much as you don't like decimals. So let's get rid of them. All we got to do is move the decimal points in what direction? Correct, to the right. Now, they all have to move the same number of places. So how many places would you have to move this one? 2. So that means everybody's going to move how many places? 2. Okay, I'm a creature of habit. I'm a visual person. I like to see it. So I move this 2 places. That becomes 12x. If I move this 2 places, negative 72. If I move this 2 places, 006 is what number? That's just a 6. If I move this decimal point 2 places, 008 is just an 8. And if I move this decimal point 2 places, what am I going to have to put here? Good, your placeholder is 0. So that becomes the number 70. Now, step 3, we're going to collect like terms. So we have a CLT here. 12x and 6x is 18x minus 72 equals 8x minus 70. We're going to move our variables always in what direction? To the left. 10x minus 72. This is going to cancel. Additive inverses. Remember, adding the opposite cancels. Got a negative 70. We're going to move our numbers to the right by doing the opposite. Subtract 72 and add 72 cancel. They're additive inverses. A negative 70 and a positive 72. They're different signs, so you subtract. Give the sign a larger. Last step is usually division. We're going to divide by 10. Okay, guys and gals, here's our common mistake in college algebra. What answer is acceptable? First of all, basic facts. 2 divided by 10 is not 5. Okay? If I had $2 and I divided them among 10 of you, would you each get $5? No, you would not. You have to remember when you have a fraction, if the numerator is smaller than the denominator, the answer is going to be a fraction. No way a whole number. The rule of thumb is this. Wherever the bigger number is in the fraction is where the answer will go. 2 goes into 10 5 times. I agree with you. But the 5 doesn't go to the numerator. The bigger number is 10. The 5 would go in the denominator. You can't leave the numerator blank, so it's understood to have a 1. So 2/10 is not acceptable. It will reduce to 1/5. But that is a fraction. And as you all know, all fractions can be converted into decimals. So if you are allowed to use a calculator and you type in the calculator 1 divided by 5, if you had $1 and divided it among 5 people, they would each get 20 cents, which is a decimal, is 2/10. That's a decimal that terminates or stops. There's no pattern to it, doesn't repeat. So that is acceptable answer. So we would accept either one. But there's your trick for getting rid of decimals. Now, let's go back to the notes. Okay? Not only do we have a trick for getting rid of decimals in our equations, we have a trick for getting rid of fractions. And that's our next big problem. You are just like me. I do not like fractions, especially if I'm not allowed to use a calculator. So in college math, you should have already learned this, but if you haven't, you're going to find out it is very important to learn how to get rid of the fractions in equations. You'd much rather deal with whole numbers. The major concept here is we got to use something we learned in 3rd grade. To get rid of fractions, you need, it says in the notes, the LCD. Well, what does that stand for? LCD is an abbreviation for least common denominator. So let's go to the whiteboard and talk about that. Okay, here is my equation. There are no parentheses. So the next goal is I don't want to have to move fractions. I'm going to make a mistake. So let's get rid of them. To get rid of fractions, you need the least common denominator. So the first question is what numbers are in the denominator? There's a 4, a 2, and a 3. What you were trying to find out, which you learned this way back in elementary school in 3rd grade, and we reviewed it in developmental, is the least common denominator is a number all 3 of these have in common on the multiplication tables. It's a number all 3 of these divide into. So if you say your multiplication tables, 4, 8, 12, 16, 20, ... 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, ... 3, 6, 9, 12, 15, 18, 21, ... All 3 of these have a number on the multiplication tables that they have in common, and you want the least, the smallest, and that number was 12. Now what you're going to do with that number is you're not going to put it in the denominator. You're trying to get rid of these numbers. Do you realize if you could erase that, you would have a whole number and it'd be much easier to work with? So think about this. These are all fractions because they have these fraction bars. Fraction bars are what operation? That's right, that's division. How do we get rid of division? Well, we learned this. We do the opposite. What's the opposite of division? Very good. That's multiplication. So what we're going to do is we're going to take our LCD and we're going to multiply the LCD to every term. And remember, you got to multiply to everybody to keep balance. So you're going to see me say, put a parenthesis to show multiply, I'm going to multiply by 12. Put a parenthesis, I'm going to multiply by 12. Put a parenthesis, I'm going to multiply by 12. Now, if you look closely, I put the 12s in the numerators. I didn't put it in the denominator. Because think about this. If you wrote 12 as a fraction, it would be 12 over 1. So we really don't got to write the divide by 1. So what you got to understand is you're going to take that LCD, you're going to multiply the LCD to every term, and it's going to go in the numerator. Now, think about this. You now have written here 12 times 3 divided by 4. I said multiply and I said divide. According to order of operations, your famous please excuse my dear Aunt Sally, which one do you do first? Does multiply go before divide? Does divide go before multiply? Well, if you had a good teacher, you should recall that multiplication and division are equal. Mom is not better than dad. M does not go before D. They are equal. They go in whatever order you want to go. So if you remember from elementary algebra, I can multiply first, do 12 times 3 and get 36, but then 36 divided by 4 is 9. Why multiply and make the number bigger first when you could divide and make it smaller? So because multiply and divide are equal, you'll always see us, the next step will be to divide the denominator into that LCD. So we're going to say, okay, look at this. 3 doesn't divide by 4, that's why we had a fraction. But 4 can go into 12 3 times. So now we have 3 times 3x. No more fraction. And we're going to do it here. 2 divides into 12 6 times. So now we have negative 6 times that 1. No more fraction. 3 divides into 12 4 times. Well, now we have 4 times 1. No fraction. And that's the beautiful thing. You did the trick. You got rid of the fractions. So now if you multiply, you got 9x minus 6 equals 4. If you look very closely, guys, this is no longer an equation with fractions. It's a nice linear equation that you all know how to solve. You add 6, 9x equals 10. You divide by 9, and x equals 10/9, which is a fraction. You don't want to change it to a mixed number, okay? And that's because in college math, we don't work with mixed numbers. So you want to keep your answer as a fraction, and improper fractions are okay in college math. Or if you did the division out, this would be a repeating decimal. So if you do the division out, if you said how many times does 9 go into 10? 9 goes into 10 once with 1 left over. And if you remember from your arithmetic, you put a decimal point, you bring down another 0. Well, 9 goes into 10 one time with 1 left over. And 9 goes into 10 one time. So if you remember, there's a pattern here. To write a repeating decimal, you put the bar, the repentant, over the digit that's repeating. So either one of those are acceptable written down as the correct answer. But the most important thing was to understand there's a trick to get rid of fractions. It works with equations. Okay, let's try another one. So on our notes, let's go to the next one. Okay, our next equation says 5/2 x minus 1 equals x plus 1/4. So I'm looking at this linear equation. I'm saying, oh no, there's fractions. That's okay, we're going to get rid of them. What do we need to know? Very good. We need the LCD. What numbers are in our denominator now? There's only a 2 and a 4. What number do they have in common that's the smallest, the least? That's right, it's 4. So what we're going to do is we're going to multiply every term of the equation by the LCD. Not just the terms that have fractions, every term. Because it's got to stay what, guys? Balanced. So we're going to multiply by 4. 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 Good? Now, remember, you could do 4 times 5 and get the 20 and then divide it by 2. But why do that extra work? Let's do the division first. The division is the easier part. 2 goes into 4 twice. That leaves us now 2 with the 5x in parentheses. We lost the denominator. This is just negative 4 times 1 because there is no division here. This is just 4 times x because there is no division bar here. But this term has division. 4 divided by 4 is what, y'all? Very good, it's 1. And that's just 1 times 1. Now you have a nice linear equation. We'll do our multiplying. 10x minus 4 equals 4x plus 1. We're going to move our variables to what side? The left. Good, so we're going to subtract 4x. We're going to get 6x minus 4. These are your additive inverses. They cancel out. That equals 1. We're going to add 4. Cancel out. 6x equals 5. We're going to divide by the coefficient in front of x, which is 6. And we get x equals 5/6. Fractions are acceptable. You're going to learn that we much rather see the answer as a fraction versus a decimal. But if you wanted to do the division or you wanted to pull out your calculator and see how many times 6 goes into 5, because that's what you're saying. $5 divided among 6 kids. Well, 6 doesn't go into 5, so you have to put the decimal point, add the 0. 6 goes into 50. If we know our times tables, that would be 8. That's 48 with a remainder of 2. So we put another 0, bring it down. 6 goes into 23 times. That's 18. Oh, look, the remainder again is 2. So we put another 0. 6 goes into 23 times. We see a pattern. What digit is repeating? The 3. So we would accept the fraction 5/6, or we would accept the repeating decimal 83/100ths, and you just put the bar, the repentant, over the 3, because the 3 is repeating. Everybody's good? Great. Let's look at one more with fractions. Okay. All right, so if you look at equation 3 here, we have x minus 3 over 4 equals 5/14 minus x plus 5 over 7. So again, if you look closely, you have an equation here. It's linear. The x's are to the first power. But guys and gals, you cannot move anything yet. You have those fraction bars. You have fractions. So the best thing to do is get rid of the fractions. You need the what? LCD. So let's look again at what we have in our denominators. We have a 4, a 14, and a 7. Now, what number do they all have in common? Here's a helpful hint. Start with the bigger number. So if you did the multiplication tables of 14, 14 times 1 is 14. 14 times 2 is 28. 14 times 3 is 42. What number do they all divide into? Very good. 4 and 7 and 14 all can divide into the 28. So that's going to be our LCD. So where are we going to put our LCD, guys? Very good. We're going to multiply it to the numerator. We're going to multiply it to the numerator. To the numerator. Okay? Are we actually going to do the work and multiply first? No, we're going to do the division first. We're going to get rid of the fraction. 4 doesn't divide into x minus 3, but 4 divides into 28 7 times. That leaves us 7x minus 3. Bring down your equals. 14 divides into 28 2 times. That leaves us 2 with the parentheses 5. Don't forget the minus. 7 divides into 28 4 times. That leaves us 4x plus 5. Now look at that. Now what are you guys going to do? That's right. We're going to have to get rid of the parentheses, so we're going to use distributing. 7x minus 21 equals 10 minus 4x minus 20. What should we do next? Perfect. Step 3, we got some collecting like terms. We're always going to collect like terms before we start moving. So that negative 4x is going to stay. 10 minus 20 is negative 10. Now, Miss Black's rule of thumb is you move the variables to the left. So we're going to add 4x. 7x and 4x is 11x minus 21 equals negative 10. Numbers move to the right. We move adding and subtracting first, so we add 21. And if you look, I'm showing you every step because this is what you need to do in college algebra. You can't do this in your head. You have to show your work. This cancels. They're additive inverses. A negative 10 and a positive 21 you would subtract and get 11. You're not done. You have to divide by the coefficient in front of the x. You divide by 11. 11 divided by 11 is 1, but we don't write 1x. We just write x. But over here, 11 divided by 11 is 1. Everybody's good so far? Great. So now I've showed you a second good trick. Now, I do want to take you back to the notes to show you something else. Okay. There is another way to get rid of the fractions. The third little trick I want to show you has to do with the fractions again, but now it's dealing more specifically with a special type of equation with fractions. You may have heard this name before. It's called a proportion. A proportion is when you have one fraction on the left and one fraction on the right of the equation. And that's it. There's no other terms. There's a fraction equals a fraction. And believe it or not, you did this in elementary school. To solve an equation that is called a proportion, instead of getting the least common denominator, you could do the trick which was called cross multiplying. And that's what I want to review with you last on this set of tricks. So let's go back to the whiteboard. All right, so here we go. We have x over 6 equals 2/3. That is a linear equation. It has x to the first power. It has fractions. There's a quicker way to solve this one without worrying about the least common denominator. It is called cross multiplication. But you can only do cross multiplication when you physically have one fraction on the left and one fraction on the right. And that's it. When I was teaching elementary school, we would call this crisscross applesauce. You're going to make two loops. And it doesn't matter which loop you multiply first. My rule of thumb is you multiply the loop with the variable first because you want the variable on the left side. So you're going to say x times 3, and that's going to give you 3x. Then you'll put the equals, and then you'll do the other loop. 6 times 2 is 12. And by cross multiplying, look what you did. Do you see any fractions? No. But the thing about this trick is, guys, you can't use it on the equations we did previously. It can only be an equation that has one fraction on the left and one fraction on the right, and that's it. And then this is easy to solve. We would divide by 3, and x equals 4. Now, for all you non-believers, if I came up here and did what I taught you, get the LCD, what is the least common denominator of 6 and 3? Very good, it's 6. So if I did that trick by multiplying by the least common denominator, look, we're going to get the same thing. Because 6 divided by 6 is going to cancel out. There's your x. 3 goes into 6 2 times, and 2 times 2 is 4. So the method that always works to get rid of fractions is doing the LCD. Always. But if you want to see a proportion and get rid of the fractions, you can do the cross multiplying. So let's finish up with our last example in this module. So we have 3x plus 3 over 5 equals 2x plus 6. Again, rules are rules. Step 1 in solving a linear equation is to get rid of what, guys? Parentheses. So you're right, you have to distribute first. That's 3x plus 9, and it's all over 5. See how far that bar goes? That's all in the numerator. That is, in algebra, a fraction, one fraction, equals 2x plus 6. And you can make anything in math a fraction by putting a fraction bar and putting the denominator as 1. When I do that, one fraction on the left, one fraction on the right. This is called a proportion. So I'm going to do my cross multiplying. Because both loops have an x in them, it doesn't matter which loop I do first. So I'm going to do this loop first. 5 times 2x plus 6. Now to multiply 5 times 2x plus 6, we're going to have to use what property? Very good, we're going to distribute. So that's going to be 10x plus 30. Then you put your equals, and then you do your other loop. 3x plus 9 times 1. Well, we all know multiplying by 1 doesn't do anything. It doesn't change it. So that's just going to leave us with 3x plus 9. And now we'll move our variables to the left. Don't I sound like a broken record? Yep, because we're doing the same steps over and over again. And we're going to move our numbers to the right. So we get 7x equals negative 21. We would have to divide by 7. So let me write that over here. And x equals negative 3. So the moral story in this module is real simple. Linear equations are not just going to only have integers, whole numbers. They're going to have fractions and decimals. And if you'd rather not deal with fractions or decimals, I gave you today some tricks to get rid of them. If you want to leave the fractions and decimals in there, be my guest. But it's just going to make things a little bit more complicated for you when you're solving. And down the road, you're going to see we're going to use these tricks as we're going on. All right, I'll get you in the next module. Thank you.